position, and this is a particle. This is a path. Anything? Okay, I just the particle is moving in a plane. Okay, the position versus time graph here. So I want to find out the velocity. This one. So what it's telling is, if you draw a tangent at this particular point, the tangent drawn at that point will give the instantaneous velocity. What is the meaning of this? Actually, like at t equals 0, we'll do one thing. Let me put another mathematical. So I was just telling you, that delta t tends to 0. So the meaning of that we'll try to explore here. Okay, if I have a particle position vector of this r1 bar, position vector of this, let it be r2 bar, and time interval t1, t2. So this will become delta t. This will become delta r. And there's a point P L2. So some other thing. Okay, and what is this curve? It's a path here. So now how you define average velocity? Average velocity, you are going to write delta r bar by delta t, which is r2 bar minus r1 bar by t2 minus t1. Displacement by time taken. Then here, if delta t tends to 0, means T2, if it comes very close to the T1, or so very close means I'm going to, let's see how much curve. Yeah. So what happened now, delta T? Earlier, this was a delta T, no? Delta T tends to 0, I'll make it. Tends to 0 means will become very small. Delta T tends to 0, then we'll call that as dt. Then this will become dr bar. Then here is what we have took the slope. So how you define the slope? Dr bar by dt, tan theta, delta y by delta x. So similarly, dr by dt. So when limit delta t tends to 0, v average bar. So this will become limit delta t tends to 0, delta r bar by delta t. This will become now instantaneous velocity, or we'll write it as dr bar by dt, or nothing but instantaneous velocity. So what I'm going to do is like this delta t, I'll make it so small. When delta t tends to 0, delta t tends to 0 will become dt. Here I'll calculate the slope. What is the slope? Like it should be dr by dt. Slope of tangent drawn at point P. So there it will give the instantaneous velocity. So let me define theta. So how to calculate in position versus time graph, or in displacement versus time graph? The slope of tangent drawn in RT graph at any instant gives the velocity at that instant, or gives the velocity at that instant, or instantaneous velocity. Okay, what do you mean by instantaneous velocity? See, like for interval, see, very simple. For interval of time delta t, what is the average velocity? Okay, we are able to tell. Instead of asking interval, I'm asking at point P, at certain time. Say at particular point means it's certain. At that instant, what is the velocity of particle? So for that, I'll make the time interval so small that delta t tends to 0. Then in the like a displacement versus time graph, there if I draw a tangent, the tangent drawn at that particular point will give the slope, and the slope of that tangent drawn in RT graph will give the instantaneous velocity. Velocity at that instant, the meaning of it. What do you mean by this? Velocity at that instant. Over an interval of time, the velocity is defined as average velocity. This delta t, I'll make it so small that it will almost tends to 0. Then at that instant, I'll measure the small change in displacement. How this dr bar will be directed again, you have to come for this one. So how this instant velocity will be directed tangential to path. How do you can say, sir, that is from this vector diagram. So how the instant velocity will be if a particle moves in a path along a certain, how the instant velocity at various points will be along its path. So there's one very generalized thing. Suppose say the particle is moving here. How the instant velocity at various points will be. So just draw a tangent there. This will be the direction of instantaneous velocity. Able to understand? So for that, what you should do, draw a tangent. That's all, nothing is there. If you just draw a tangent, this will be the direction of what is the velocity at point 1. Okay, this let me define at point 1. V1, what is the velocity at 2? V2, what is the velocity at 3? V3, what is the velocity of particle at 4? V4, what is the velocity of particle at 5? V5, what is the velocity of particle at 6? V6. And what is this? This is called as a path. Able to understand this one? So if you draw a tangent, how the instant velocity will be directed? Along the path, that one. So why it should be along the path, I give explanation. This is very important. I'm stressing so many things, that one. Okay, then this is one thing. So how to calculate it? Okay, mathematically, I have a formula, dr bar by dt. Okay, there's a one very important conclusions which I'm making it. Instant velocity or speed will be same if particle moves along a straight line. Instant velocity or speed will be same. So how you define instantaneous speed? Let me define this also, so that will be there. So instant speed. So it should be equal to, again, v in, don't write v bar here. So this should be equal to limit delta t tends to 0 dr by dt. Distance covered, it will be like r will be the magnitude of displacement. No, distance covered, it will become, oh sorry, it will be like this. Then this will become dr bar by dt. Okay, this is instant speed, like this will define. Okay, now I think somehow we got an idea. What is idea? What is the idea? Like instantaneous velocity and average velocity. What is the difference between them? Still, we are not able to understand why you are discussing that instant velocity, why you have brought it. Okay, let's do one thing. Let me introduce to an example. A particle moves along a straight line. Its position is given by 2t square, or t square, I'll write it. Very simple. So what is S? S is the position. S equals 0, the particle is here. At various instants of time, let's go for the slope. S is in meter, position. T is a time in seconds. So what is S? S stands for position of particle. Okay, at t equals 0, particle will be at origin, the reference point. At t equal to 1 second, it will be at a distance of 1 meter from origin. 2, 4 meter. 3, it will be 9, 4, 16. At t equal to 5 seconds, it will be 25 meter. 6, 36, 49. Okay, this is what I'm going to indicate this one. So let me take this is 10, 20, 30, 40, and 50. At t equal to 0, it will be at origin. At t equal to 1 second, it will be at a distance of 1 meter. At t equal to 2 seconds, it will be at a distance of 4 meters. T equal to 3 seconds, it will be at a distance of 9. 16, it will be here. 25 at 5 seconds, 36. 49, it will be here. Look at now. In first 1 second, it will cover 1 meter. Next 1 second, it will cover more distance. Okay, this is no problem. No, let me ask you, what is the average velocity? Average velocity for 0 to 5 seconds. Find a particle. Let me write all the description. A particle is moving along a straight line such that its position varies with time as s equal to t square. Find average speed or velocity, both are same. Average velocity for t equal to 0 to t equal to 5 seconds. For interval of time, find average velocity for time interval 0 to 5 seconds. For time interval t equal to 0 to t equal to 5 seconds. And velocity of particle at t equal to 5 seconds. I think very, very, very important question is what I just brought it. So what is asking? So there are for 5 seconds, for interval of 5 seconds is asking what is the average velocity. At 5 seconds is asking velocity. I think the difference is totally different there. So it's asking velocity of particle at 5 seconds. At means instant, at that instant. For an interval, it's another one. So what shall we do here? How to calculate average velocity? So for first 5 seconds, the formula is very simple. V average equal to delta S bar by delta T. So 25 minus 0, 5 minus 0. How much it is? How much it is? So it will be 25, 5 meter per second. Then at 5 seconds is asking. I think there's a lot of differences. You know, for 5 seconds, what was the average velocity? At 5 seconds. At 5 seconds, what shall I do? I should calculate ds by dt. How to calculate ds by dt? I'll go for the plotting of graph. Let's plot. So what are the intervals of time? 1, 2, 3, 4, 5, 6, 7, 8. Let this be 10, 20, 30, 40. This is the position. And t is in seconds. So let me go for the graph. At t equals 0, it will be 0. T equal to 1, it will be 1 meter. T equal to 2, it will be 4. T equal to 3, it will be 9. Rough graph. It will be 16. 5, it will be 25. 6, it will be 36. 7, it will be 49. Okay, this is our experimental curve. May not be exact parabolic shape to some extent. Okay, let's get into the question that is asked. You have to calculate at 5 seconds, what is the velocity, no? So what shall I do? There are two things are there. You have to calculate ds by dt. How to calculate ds by dt? If you know s equal t square, so ds equal to 2t from differentiation tool. So ds by dt is what? 2t. This should become instantaneous velocity at t equal to 5 seconds. This instantaneous velocity, how much it is? (10 meters per second). This is using differentiation tool. Another method, draw a tangent. What you have to do? You have to draw a tangent. Where you have to draw? You have to draw a tangent at t equal to 5 seconds, corresponding to t equal to 5 seconds. Tangent. I think I'm unable to draw it. Oh, no. Just extend. Okay, make it a very big line. This is the tangent. Let me choose that point. Tangent drawn. So now you can ask questions. So why you are drawing tangent? Why you are drawing tangent at 5? Because at t equal to 5 seconds, I should calculate instant velocity. So what shall I do is like a corresponding to t equal to 5 seconds. So what you should do, corresponding to t equal to 5 seconds, you locate a point on a curve. The point will be at. So there you draw a tangent. Then the slope of tangent should be the instant velocity. How to calculate the slope? I think you know. So you can take protractor and measure this theta. This is nothing but v instantaneous, which is equal to tan theta. How to measure theta? Theta measured by protractor. Slope of tangent drawn at that instant corresponding to the instant at which you are calculating, that should be the instant velocity. So there are two methods are there. One, graphical method. What graphical method says? Corresponding to t equal to 5 seconds, locate a point on a curve. There you draw a tangent. Then the slope of the tangent drawn at that particular point will give instant velocity. How to measure this theta? Tan theta. So first you measure theta using protractor, then tan of that will be instant velocity. Or else another method is what? This is the method 1. This is method 2. This is using geometrical instrument. This is using differentiation. I think this will be much easier. No? Every time we can't draw this. So this is a question that is asked. Are you getting no? So what is it? Why we should learn that differentiation? Graph, plotting graphs. Initially, I think I thought all those things. The necessity is this one. So the question was asked like this. Find the let it get saved. The question was asked, no? A particle is moving along a straight line such that its position varies with the time. This is the thing. Find average velocity for time interval 0 to 5 seconds and velocity of particle. This velocity of particle at t equal 5 seconds, this is instant velocity. How to calculate average velocity? We know displacement by time taken. In 5 seconds, what is the displacement? At t equals 0, it was at origin. After 5 seconds, it was at 25 meters. So 25 minus 0 by 5, 5 meters. Average velocity, there's no problem. How to get the instant velocity? Velocity at 5 seconds. So like still we are not understanding. Okay, nowadays, see, we are in the 21st century. You are moving on a bike. I'll ask you, what is the speed of with what speed you are moving the bike? So what you are going to do? You are going to look at the speedometer, no? At that instant, what is the speed of the bike? Just look at the nowadays digital displays are there. It will display the 25 kilometer per hour. Yes. So what that speedometer of a bike will indicate? The instantaneous speed, not instantaneous velocity. So speedometer a bike indicates instantaneous speed. It will not indicate direction. Only it will tell with what speed you are moving. Instantaneous speed or speed of the bike at that instant. So how you define instant speed? At that instant, with what speed you are moving, that is what indicated. So what is it there? Like there's a device. It will indicate the instant speed. If I give you some equation like this condition, how to calculate instant speed? By differentiation tool, this will be much easier. No? Just take the first derivative of it. The rate of change of displacement is what? Instant velocity. Put time t. So I want now what is the instant speed of the particle at various instants of time at t equal to say 6 seconds. So what you should do, again draw a tangent corresponding to a point at t equal to 6 seconds, means 6 seconds. So you locate the point, draw a tangent. Then again measure the theta angle made by the tangent with the horizontal. Tan theta will give instantaneous velocity. This will be graphical method. This will be much easier, no? So how to calculate the speed of particle at any instant? So let me extend this graph here. For various instants of time, we'll just discuss the instantaneous speed. This is one thing. Okay, now again, what is the speed? V instantaneous. Or you can also write only V at t equals 0. So what is the formula? V is equal to, what is the formula? V is equal to how much? V instantaneous 2t, no? Instantaneous or okay, I took only symbol. So how much here will be 2, 4, 6, 8, 10, 12, 14. This will be much easier. Use this formula. Or else what you should do at t equal to 5 seconds, what is the instantaneous speed? 10 meters. At t equal to 4 seconds, what is the speed of particle? 8. Average velocity is different. So what is average velocity? So what you should do for the interval of time? For 0 to 5 seconds means again displacement 25 by 5. 0 to 6 seconds means, so what you're going to do? 36 by 0 to 7 seconds, so 49, that one. Like this you can go for. No, from 9 to, select from 3 to 6 seconds. What is the average velocity? Yes, you can calculate here. So average velocity is something you can calculate from here. You draw a graph. Then delta S and delta T locate it. Then the ratio of that will be the average velocity. Okay, this is, I think I'll bring that average velocity, how to calculate average velocity graphically. Okay, we have everything here, no? No, what is the interval of time? Let me pick up interval of time. 3 to 5 seconds. Or 2 to 4 seconds. Let me pick up. To draw it. Yeah. Okay, this is the now what I'm doing, I'm just showing how to calculate the average speed or average velocity. Since particle moving along a straight line, no, so both will be same. What was our question that was asked? 0 to 5 seconds. No, let me stick on to my question. 0 to 5 seconds. And I had to shade till here. There's a initial basic concept. No, I'm just spending more time. Yeah, this is a conceptual one. This will be the Like this, you can change that interval 0 to 5 seconds. So what you are going to do, 0 to 5 seconds, delta t it is, and here you calculate delta s. So V average is what? This will be much easier. There's no problem. I think you know you have studied in high school. The ds by dt is the first time is what you are seeing. There's nothing but the derivative of the function. So how you define instantaneous velocity? ds by dt. So at least now you are able to understand what is the difference between delta s by delta t and ds by dt. Delta s by delta t will give average value. ds by dt will give instantaneous value. That's why the instant velocity we define it as rate of change of displacement. Average velocity, displacement by time taken. I think there's a difference there. So two methods are there: graphical method, another by finding out using differentiation tool. What is a graphical method? How to calculate instant speed? Corresponding to point at t equal to 5 seconds. Corresponding to point 5 seconds, locate a point on a curve, draw a tangent there, find the angle made by the tangent with the horizontal, then tan theta will give instantaneous velocity. Okay. Then how to calculate average velocity? Just in the graph, calculate for corresponding delta t, what is delta s? Ratio of that will be average velocity. Agreed? That's what I wanted to just convey the basic concept. Okay, now speedometer in a bike will indicate the average speed or instantaneous speed. Will be instantaneous speed. Okay, from velocity, I'm migrating to here average the instant speed, no instant velocity. Then if a particle moves along a straight line, then instant velocity will become equal to instantaneous speed. Let me adjust this content. I think things are very clearly visible. Okay, fine. So we'll move to the next content. So if you know instantaneous velocity, so can you calculate the displacement and the average velocity? The answer is yes, because what is the formula? V instantaneous is equal to dr bar by dt. So dr bar by dt, you can also write V instantaneous dt. This I'll integrate. So this integral of dr bar by dt will give will give the displacement vector. In books, usually displacement will take it as bar, no? We'll use this typical symbol. This will be better. So if you know instant velocity, can you calculate the displacement using this formula? Similarly, if you know instant velocity, can you calculate average velocity? Yes, the formula is same. V average velocity equal to integral of so if you know instant velocity, you can calculate average velocity. If you know instant velocity, you can calculate displacement. Similarly, if you know instant velocity, can you calculate the distance? Yes, it will be the distance here. V instantaneous equal to ds by dt. Instant speed equal to ds by dt. So ds equal to V instantaneous dt. This I'll integrate. I'll get the distance. Distance covered, will write it. Similarly, average speed, this is average velocity. Similarly, average speed. Take mod of that, that will give the average speed. So if you know one quantity, you can predict remaining all other quantities. There's the idea of this instantaneous speed. So what is instant speed? What is average speed? Velocity at that instant, I'll call instant speed. Usually what is the symbol? V instantaneous. In some books, they call V in. And if I don't write any suffix here, then it is said to be instantaneous. If I average, I will mention AV, that one. Instant speed, no? So gradually we just write only V. So it is understood. It's instantaneous velocity or instant speed here. Some books they write V in, some instantaneous INST will be indicated. So rate of change of displacement will give instant velocity, rate of change of position will give the distance. So if you know one quantity, we can predict the remaining other quantities also. Okay, let me